Hello friends, this is Priyanka. Today we are going to solve a problem on fluctuating loads on power plant. In this video we are going to draw load curve as well as load duration curve. We are also going to calculate load factor, capacity factor and use factor for the base load plant as well as peak load plant. Here table is given for the time as well as load in kilowatt. So if we observe this table here, time is from 6 to 8 am and load is 8000 kilowatt. Then 8 to 9 am 16,000 kilowatt, 9 to 11 am 20,000 kilowatt, 11 to 2 pm 12,000 kilowatt, 2 to 5 pm 14,000 kilowatt, 5 to 8 pm 20,000 kilowatt, 8 to 12, so 12 at night 10,000 kilowatt, 12 to 5 am 5,000 kilowatt and 5 to 6 am 6,000 kilowatt. So this is the table given. Now I will read the question for this table. Draw the load duration curve and find the power required for 50% of the time of the day. If the capacity of plant is 25 megawatt, find the capacity factor of the power plant. If the load is supplied by two power plants, one is acting as a base load plant having a capacity of 15 megawatt and other as a peak load plant having a capacity of 10 megawatt, find load factor, capacity factor and use factor for both power plants. So this was the given question. To draw the load duration curve, we will first draw the load curve. Now if we observe this table here, the time is given in the form of morning, then afternoon and night. So it is the total time duration is 24 hours. So we have to plot this total time duration 24 hours on this horizontal line. And we have to plot the time in same format as given in the table. So it is given 6 to 8 am. So we will plot here or we will divide here total time period 24 hours into 12 parts. And then each part will be for 2 hours. So here 6 to 8, 8 to 10, 10 to 12. So here after morning there is noon. So 12 at noon. Then again here after noon there is time is in PM, that is 2, 4, 6, 8, 10. So here it is PM and here 12 is at night, and again after night the time is in the morning, that is 2 am, 4 am and 6 am. Now on vertical line we will plot here the load. So load is given in kilowatt, we will convert this into megawatt. Now if we observe minimum load is 5,000 and maximum is 20,000, that is minimum load is 5 megawatt and maximum load is 20 megawatt. So we will make here the partition, that is from 0 to 2, 4, 6 up to 22. So on this vertical line the load is in megawatt given. Now how to draw the load curve? So we will move for the first, that is the time duration 6 to 8 am. So here 8 is given. So from this 8 we will draw one vertical line. So I have drawn here some vertical lines from this given time. So with the help of red marker. So these are the rough lines. Now for 6 to 8 am load is given 8,000 kilowatt, that is 8 megawatt. So for this time period I will draw here one vertical line. So here time period is 6 to 8 and load is 8 megawatt. Then 8 to 9 load is 16 megawatt. So for the time period 8 to 9, so we have to select the middle point in between 8 and 10 and load is given 16 megawatt. So here is 16. So we will draw here one horizontal line. Now we will join this. Then again 9 to 11, 20 megawatt. So for this 9 to 11, 20 megawatt. So this is the vertical line for 9 and this is for 11. So again we will join these two lines for this 20 megawatt. So again we will join these corners. Then 11 to 2, 12 megawatt. So here is 11, here is 2. So for this 12 megawatt, we will draw one line. So we will join this corner. Then 2 to 5, 14 megawatt. So here 2 and here is 5. So from this 5 also I have drawn one vertical line. So now we will draw here for 14 megawatt one horizontal line. That is 2 to 5. Then 5 to 8, 20 megawatt. So here is 5, here is time 8. So for this we will join the line for the 20 megawatt. Now we will join this corner. Then 8 to 12, 10 megawatt. So here is 8 and here is time 12. So it is 10 megawatt. So 10 megawatt is here. So with this horizontal line we will join this. Then 12 to 5, it is 5000. So here is 12 and here is 5 is in between 4 and 6. So it is 5000, that is 5 megawatt. So 5 is in between 4 and 6. So we will divide here, or we will make the partition, and for this 5 we will draw one horizontal line. And then 5 to 6, it is 6 megawatt. So here for this 6 megawatt also we will draw one line. We will join this. So this is nothing but the load curve that is getting completed. Now from this load curve we will draw the load duration curve. So how to draw the load duration curve? So for that we will rearrange these loads from minimum load to the maximum load. So I will again make here one separate table to draw the load duration curve. So we will refer this table to draw the load duration curve. So here is 5000, 6000. So I will take here load in kilowatt. Then time duration. So this is the load duration curve. So we will select for particular load what is the time duration that we have to write, and then we will calculate the percentage of time. So for that first we will take the minimum load, that is 5000. After that 5000 it is 6000. Then 6000, then 8000. Then after 8000 it is 10,000. Then here is 12,000. Then 14,000. Then 16,000. And last one is 20,000. So this 20,000 is getting repeated here in between for 9 to 11 and 5 to 8. So here are all the numbers are getting covered. So for these loads we have to select the time duration, because here particular time is given, but now we have to take what is the time duration. So how to take this time duration? Now if we observe, the minimum load is 5000 kilowatt. So that means 5 megawatt. So for this 5 megawatt, from this load curve only we have to write this data. Now for this 5 megawatt, if we observe what is the time duration. So this 5 megawatt is active for all 24 periods of time. So this 5 megawatt, if we observe here this minimum range is 5 megawatt, so we have to take, so what is the time duration? So here total duration is 24 hours, so I will write here as a 24. Now we will move for the 6 megawatt. Now if we observe for the 6 megawatt, how we can measure this total time? So now I will make here one construction line. So for this 6 megawatt, I will draw the total time period with this, I will show this gap. So for this 6 megawatt, and here this gap also is getting included. So I will make here one notation, that is I will say A1 A2. So this is A1 and this is A2. So A1 plus A2 is the total time period for 6000 megawatt. So out of this total 24 hours, this 5000 this 5000 kilowatt is in between for 12 to 5. That means out of this total duration 24 hours, we have to subtract this number of hours, that is total number of hours 5. So this total number of hours 5, if we subtract from this total 24 hours, then 24 minus 5, that is 19. So we will write here as a 19. Then we will move for the next, that is for 8000 kilowatt. So 8000 kilowatt, that means 8 megawatt. So again in the same way we will write this. So we have to consider the time period. So I will draw here one horizontal line. Now if we observe, here is the total duration. So I will use here the notation as a B1. So for this B1, how to measure this total duration? So out of this total 24 hours, we have to skip this number of hours, that is from 12 to 6. So this 24 minus 6, that is equal to 18. So B1, value of B1 is nothing but 18. Then 10,000. So for this 10,000 also we will make here. So I will show this with letter C1. So how to measure this 10,000? So I will show here the time duration. So for this 10,000, that is 10 megawatt. So this is nothing but, I will say C1. So what is this total time period? So out of this total 24 hours, we have to subtract this 6 and here 2 hours, that is 6 plus 2, 8. So 24 minus 8, that we have to write. So here will be 16. Then for 12,000, that is 12 megawatt. So again I will show here for this 12 megawatt what is the total duration. So for this 12 megawatt, here the total duration I will show. I will use here the letter D. So here is the D1. So for this D1, how to measure this? So this out of total 24. So from this 8 to 6. So here 8 to 6, that is 2 plus 2, 4, 6, 8, 10 minus this 2. Here is also gap. So 1, 2, 3, 4, 5, 6. That is 24 minus 12. So here will be 12. Then for 14 megawatt. So for this 14 megawatt also we will draw here the time period, or I will show here the time period. So here this horizontal line we have to consider. So this is, I will use here the E, and here is also there are 2 time periods or 2 durations. So I will use here the letter F. So here is F1 and here this duration is F2. So we have to subtract all the other durations. So how to subtract this? Total is 6 to 8, that is 2. Then here in between this gap is from 11 to 2. That is total is 3 plus 2, 5, and after 8, that is 5 plus I will say 2, 4, 6, 8, 10. That is 15. So 24 minus 15, that we have to write. That is equal to 9. Then again we will move for the 16. So for this 16 megawatt, again we will use the same. That is, I will use here the letter G. So here this is the duration, that is G1, and here is second duration, that is G2. So we have to add these two durations. So we can subtract the other and we will calculate here. That is in between this 11 to 5. So 11 to 5, that means total 6. 6 plus 2, that is 8, and after this 8 and here 2, 4, 6, 8, 10, that is 18. So 24 minus 18, that is 6. And for this 20, if we observe here, I will use the letter H. So here this duration we can clearly see, here is H1 and here this, for this horizontal line it is H2. So we can measure here from this point also. So this duration is from 9 to 11. So 9 to 11, that is 2 hours, and here from 5 to 8, that is 3 hours. That is, here will be number 5. So in this way, this is very important calculation. Now we will move for the calculation of percentage of time. So how to calculate the percentage of time? So if we observe, out of 24 hours, this 5000 kilowatt load or 5 megawatt load is present for all this duration. That is all this 24 hours. So here percentage of time is 100%. Now it is important, that is we will I will show here rough calculation also. So how to calculate? So the second number is for 19 hours. So from these 24 hours, this 6 megawatt load is available for 19 hours. For 19 hours. So out of 100, how many percentage is there? So 19 multiplied by 100 divided by 24. That is 79.16. So I will take here 79.2. So in the same way we have to calculate the percentage time. Remaining percentage of time is getting calculated: 75, 66.7, 50, 37.5, 25 and 20.8. Now we will move to draw load duration curve. So how to draw that? Here we have to plot on this horizontal line percentage of time. Now if we observe, this percentage is from 0 to 100. So we will make here 10 equal parts and we will plot 10, 20, 30 and so on up to 100. And on vertical line we have to plot the load in megawatt. So we have to plot the same load, that is we have plotted in this load curve, that is maximum load here, that is 20 megawatt. So for this 20 megawatt, from 0 to 20 we have to make equal parts and we will plot here the load, that is 0 to 4, 6 and so on up to 20. Now I have drawn here some rough lines, that is with the help of red marker. So if we observe, for this given percentage, that is 20.8, then 25, then 37.5. So for this particular numbers I will draw here, or we have to draw here some rough lines. So it will make easy for us to draw the load duration curve. Now how to draw this load duration curve? So we have to take the load in descending order. That is, maximum load is 20 megawatt. Then duration for this, time duration for this load is 5 hours, but on the horizontal line we have taken the percentage of time. So for this maximum load we have to refer this percentage of time. So up to this 20.8% of time we have to take the load equal to 20 megawatt. So here 20.8. So here is the vertical line which is equal to 20.8%. Now I will draw here one horizontal line and this is the first line, that is for maximum load. Then the next load after 20 megawatt is 16 megawatt. So for this 16 megawatt it is here 25%. So up to 25% here is the next load, that is 16 megawatt. So if we observe here, here is the 16 megawatt and here the line that is shown for the 25%. So I will draw here the next gap, or I will fill up here the next gap with 16 megawatt. So I will join this corner. Then next is 14 megawatt and it is up to 37.5. So here is the line for 37.5 and load is 14 megawatt. So for this 14 megawatt I will draw here one horizontal line and I will join these corners. Then 12 megawatt. So for 12 megawatt it is 50%. So for this 12 I will draw the line up to this 50%. I will join this corner. Then again 10 megawatt 66.7. So here is the line for 66.7 and the load is 10 megawatt. So I will join these corners. Then next is 8 megawatt and up to 75%. So here is the line for 75% and load is 8 megawatt. So I will draw here. Then next is 6 megawatt and 79.2%. So for 6 megawatt it is 79.2%. So I will draw here one line and I will join this corner. And then minimum load is 5 megawatt and 100%. So for this 5, that is it is in between 4 and 6. So we will select the middle point and we will draw this horizontal line up to 100% and we will join this corner. And we will join this. So this is the curve in the descending order. So this descending order is about load and this is known as the load duration curve. Now what is the question? Question is that we have to find out the required load for 50% of time. So how to find out? So it is the percentage of time and we have to refer this load duration curve. So for this 50% of time I will draw here one vertical line passing through this 50% and then we have to find out the required load. So for this required load here is the point of intersection. So if I draw again one line, then here this required load for 50% of time is 10 megawatt. So answer is 10 megawatt. Now we have to find out the capacity factor. So to find out this capacity factor, we will first calculate what is the total energy generated. So this total energy generated we have to calculate from this load curve. So what is this total energy generated? That is the area under this curve. So how to calculate the area under this curve? So there are different sections. So suppose if I join these sections, then we will observe this. So this area under the curve is nothing but addition of all these areas. So this area, suppose how to calculate this first part. So this first part is in the form of rectangle. So how to calculate the area? That is this horizontal distance. So this distance is in hours, that is time, 6 to 8, that is 2 hours. And this vertical distance is in load in megawatt, that is from 0 to 8. So I will write here 8 multiplied by 2 plus we have to take the second area, that is 8 to 9, that is 1 hour duration, and what is the load? That is 16. So 16 multiplied by 1 plus, now we will refer this third area, that is 9 to 11. So here total duration is 2 hours and load is 20. So 2 multiplied by 20 plus, now 11 to 2. So for this 11 to 2, that is for 3 hours, load is 12, that is 12 multiplied by 3 plus 2 to 5. So here total 3 hours and load is 14. So 14 multiplied by 3 plus 5 to 8. So here also 3 hours and load is 20. So 3 multiplied by 20 plus Again 8 to 12. So here 4 hours and load is 10. So 4 multiplied by 10 plus 12 to 5. So here 5 hour duration, and here vertical distance is for 5 megawatt. That is 5 multiplied by 5 plus 5 to 6, that is 1 hour, and here load in 6, that is 1 multiplied by 6. So if we observe, we have to make the multiplication first and we have to add all these numbers. Now we will calculate capacity factor. So what is the formula for capacity factor? That is the total energy generated. We have calculated, that is 281 megawatt hours divided by capacity of the plant into time period. So capacity of the plant is given 25 megawatt and time period. So this load curve for this time period of 24 hours. So we have to take here 24. So what is the answer? Answer is 0.468. So we will write this capacity factor in percentage. That is, we have to multiply with 146.8%. Now we will move for the next question, that is for the base load plant. Now for this base load plant, capacity is given 15 megawatt. So we will show this 15 megawatt capacity for this plant in the load curve. So here this is the in between 14 and 16, we have to select one middle point, and for this middle point I will draw one horizontal line. So below this 15 megawatt, here all this area shown by the load curve is the area for this base load plant. So what is the actual energy generated? So actual energy generated is nothing but area under the curve. So if we observe this, this is the area below this 15 megawatt. Now we will write this area under the curve. So this total area is nothing but the area of these different sections. So first we will take this first section. This is in the form of rectangle. So what is the area for this first section? That is number of hours 6 to 8, that is 2, and height is for 8 megawatt. That is 8 multiplied by 2. Plus we will take the second section or second area. So the second area is also in the form of rectangle. Now here we have to take the load up to this 15 megawatt. So if we observe, here is the rectangle, that is this time duration is 8 to 11, that is total 3 hours, and what is the height? That is 15. So 15 multiplied by 3 plus we will move for the next, that is this 11 to 2, that is 3 hours, and height is 12. So 12 multiplied by 3 plus. Now next is 14 multiplied by 3. Now we will move for the next area. So this next area is for 3 hours and height is for 15 megawatt. So 15 multiplied by 3 plus again here 4 multiplied by 10 plus here this total is 12 to 5, that is total number 5 hours, and this load is also 5, that is 5 multiplied by 5 plus here is 1 hour and load is 6 megawatt. So 6 multiplied by 1. So if we calculate this, we will get the answer 225, and what is the unit? That is megawatt hours. So this is the actual energy generated by the base load plant. Now here capacity is given for 15 megawatt. So this base load plant will work only up to this 15 megawatt. So we have to take all the area below this 15 megawatt. Now we will calculate the load factor. So load factor means what? That is this energy generated by peak load into time period. Now what is this energy generated? That is 225 divided by peak load. So here how we can consider the peak load? So if we observe this load curve, then this peak load is nothing but the capacity of this base load, that is 15 multiplied by time period. So we know that time period is for 24 hours. So we have to calculate this. So we will calculate 225 divided by, in the bracket, 15 multiplied by 24, bracket complete. So answer is 0.625. So we will convert this into percentage, that is 62.5%. Now we will move for the capacity factor. So for this capacity factor, what is this formula? That is total energy generated divided by capacity of the plant into time period. So instead of this peak load, we have to take the capacity of the plant. But if we observe this load curve, then here this capacity of the plant is considered as the peak load. So there is no any reserve capacity, and for that purpose we can say that capacity factor is equal to load factor, and which is equal to 62.5%. Now we will make the calculation for use factor, but before that make one correction, that is actual energy produced for the base load plant is 255 megawatt hours. So it is not 225 but it is 255, and we have to consider here 255 megawatt hours. So here use factor is actual energy produced divided by plant capacity into number of actual hours. So if we observe for this base load plant, it is 255 divided by plant capacity is 15 and number of actual hours, that is 24. So when we calculate this, we will get 0.708, and which is equal to 70.8%. So here plant capacity is the maximum load, or we can say peak load. There is no any reserve capacity for this base load plant. So for this base load plant, capacity factor is equal to use factor is equal to load factor. So for all these questions, the answer is same, that is 70.8%. So here there is some mistake, small mistake for the calculation of the capacity factor and load factor. So we have to correct it with 255 megawatt hours energy produced. Now we will move for the peak load plant. So for this peak load plant, capacity is 10 megawatt, it is given. So peak load plant runs only when the base load plant capacity is getting fulfilled, that is above 15 megawatt. So I have shown here the area above this 15 megawatt with these lines. So this is the area for this peak load plant. So what is the actual energy generated? So I have highlighted this area with the help of red marker, and now we have to add these two areas. Then we will get the actual energy generated, that is nothing but the area that is I have shown with this red marker. So I will write here how to add all these areas. So for this area, this is the addition of two areas. So now how we can find out the area for this small rectangle? So this horizontal distance, so this horizontal distance is nothing but 1 hour, 8 to 9. So I will write 1 multiplied by this vertical distance. So this vertical distance is 15 to 16 megawatt, that is also 1 megawatt. Plus we will add this second area. So second area is for 9 to 11, that is 2 hours multiplied by what is this vertical length, that is from 15 to 20, that is 5. Plus we will move for the next. So here is also from 5 to 8, that is number of hours, that is 3, and for this vertical line from 15 to 20, that is 5. Then we will calculate this. So which is equal to, so 1 plus 10 plus 15. So which is equal to 26 megawatt hour. So this is the actual energy generated by the peak load plant. Now we will find out what is the time period. So time period for this peak load plant is nothing but we have to take this horizontal distance. So for this horizontal distance, it is in between 8 to 11, that is total number of hours 8 to 10, 2, that is here is 3 hours plus here 3 hours. So total number of hours, that is 6 hours. So time period for this peak load plant is 6 hours. Now we will calculate the load factor. So how to calculate the load factor? Here we will take the time period is for whole day, that is for one day, or we can say for 24 hours. Then what is the energy generated? Energy generated is 26 megawatt hour divided by peak load. So for this peak load, now here for this area we have to consider the peak load. So here base is at 15 megawatt and here maximum load is 20. So what is this maximum distance, vertical distance, that is 5. So we have to take here as a peak load 5 multiplied by time period. So it is for one day. So we will consider here as a 24. So what is the answer? That is 26 divided by 24 multiplied by 5. It is 0.21. 6. So we will say that 21.6%. Now we will calculate the capacity factor. So for this capacity factor also we will take the time period for 24 hours. So energy produced is 26, capacity. Now here capacity is given 10 megawatt. So we will take here plant capacity as a 10. So 26 divided by 10 multiplied by 24. So 26 divided by 240, which is equal to 0.1083, which is equal to 10.83. Now we will move for the calculation of use factor. So for this use factor, formula is given. So here actual energy produced. So actual energy produced is 26 megawatt hours divided by plant capacity. It is given as a 10, and number of actual hours. So number of actual hours. So from this load curve we have to take this number of actual hours. So number of actual hours is 6 hours. So multiplied by 6. So here 26 divided by 60. 0.433. So which is equal to 43.3%. So these are the answers.